Okay, welcome back everyone to the next session. So I want to thank all the speakers from the first session. I think that was very informative, gives you a little bit of the background on this symposium and where we're going. So the second session, it will be our first distinguished speaker, who is Gargi Dasgupta. She is the director of the research lab in India, and she will talk about accelerating the journey to cloud with AI. But right now I'd like to introduce the session chair, Vijay Desai, who will tell you a little bit about herself, and she's another of our colleagues in India. So thank you.
Hi, good morning, good afternoon, and good evening to all for being here today at the IEEE Women in Service Computing Symposium. And I'm Vaijayanti. I work for IBM GTS Labs. And today we have a very distinguished speaker, Gargi Dasgupta from India. Gargi is a distinguished engineer, director for IBM Research in India, and the CTO for IBM India South Asia. As the director, she drives the technical agenda of IBM's India Research Labs in collaboration with IBM's worldwide research labs business units. Gargi has helped establish new research directions at the intersection of service science, text analytics, and AI. In today's symposium, like what Lauren said, Gargi would be talking about accelerating the journey to cloud with AI. She'll take us through how AI can be used for helping clients to move to the cloud. This session is for 1 hour, of which Gargi would speak for 45 minutes. The Q&A session would be at the end for 15 minutes. So please post your questions on the Q&A tab located on top of the right corner of your screens, and Gargi would address them. So please join me in welcoming her on stage. Gargi, thank you.
Thank you. Thank you, Vaijayanti. I hope all of you can hear me. But before I start my talk, I hope everyone who is watching this conference and is a part of this is staying safe, is staying healthy, and is close to their family and close to people they care about. So with that hope out to everyone, I'm Gargi, and I'm going to, I'm very excited to be here as part of the Women in Service Computing Symposium. And really what I'm going to talk about is two key drivers that we see in our technology landscape as we look forward, and how one is helping the other. And these are hybrid cloud and AI. So I'm going to just share again. All right, excellent. So let's get started. So for everyone who we talk to, whether it's clients that we work with, whether it's the governments that we partner with, or universities who have a view on where technologies are going, they will agree that there are two dominant forces that everyone in the technology space is talking about. One is the hybrid multi-cloud, and we'll talk about what that means. And the other is artificial intelligence. In fact, it's, I think, common to say that in 10 years, every company will be a cloud and an AI company. And that's a very strong statement, and we will see how one helps the other. Little bit about the evolution of the cloud and what are the factors that really are changing the landscape of cloud computing. So think of it as a three-dimensional vector where there are some changes taking place. Computing used to be centralized, done best with high-powered servers in a centralized manner with big, long, complex, monolithic applications written by people with a lot of expertise and domain knowledge. So centralized, they were all run on the same type of servers. They were mostly high-performance computing types of infrastructure and big, complex apps. They're changing all these three dimensions. The centralized computing is moving to more decentralized, which means you can do compute in a part of it in the data center, a part of it on your mobile phone, a part of it on your access point, which sits between the cloud and your device. So it's decentralized. It's not the same type of hardware or equivalent compute everywhere. The core can have very, very powerful servers, but really it's more heterogeneous devices coming together and doing compute. So for example, small edge devices can actually do a little bit of the compute that of a rendition of image recognition apps that traditionally would have been done by big monstrous servers sitting in the core. And the third dimension is of application development. Complex ERP software is now getting broken up into tiny or small services that accomplish one or maybe a handful of functions. And these are called microservices. So cloud computing is evolving. It's evolving in all these three dimensions. And this is very important for us to note because we will connect it back on how we can help along each of these three dimensions using AI. The second is an important statistic, right? Why would people care to be on the cloud? Whether it's a government institution, whether it's a commercial company, whether it's an NGO, the benefits of the cloud is immense because not only does it help you reduce operating costs, with the agility of cloud, you can actually innovate faster. You can focus on the things that matter to you. For example, a retail company which knows how to best manage its supply chain, design new products, do demand forecasting, and understand what's going to be in the next fall season is best adept at doing these things and should not be concerned about managing IT and infrastructure. There are also other benefits of moving to cloud, but that aside, let's focus on the $1 trillion opportunity that's laid out on this chart in front of you. And this opportunity is really across private clouds, which are really private data centers where you get all the benefits of cloud computing, but your data and your compute is not connected to the public cloud, or a more public economical way infrastructure that allows you to access shared services, shared platforms, and for certain types of computing and applications, that might be a perfectly acceptable policy. And then there are dedicated clouds. But across private, public, and dedicated, there's $1 trillion of opportunity, right? And this is a big shift. And when what the McKinsey report says is that when you talk to people, about 94% of them are on multiple clouds, which means they have more than one of private, public, or dedicated. So they are definitely on more than one. And then 67%, which is close to 70% of them, are with more than one cloud service provider, which means that they could be with the top 3, top 4, but they're definitely seeing benefits for certain kinds of workloads and platforms with one cloud provider, whereas they're seeing other kinds of benefits for other type of workloads with the other cloud provider. So it's really a mix, and that's what we need to appreciate. And this is why we say that most of it's going to be a hybrid multi-cloud world. So just to recap, everyone's moving to the cloud. There are benefits of cloud. Cloud is beyond operational benefits. It actually helps you design, innovate, and be best at your business at a much, much faster rate, right? It brings agility. Hence cloud. And then cloud is changing along some directions, right? Which is more heterogeneous computing, more decentralized computing, and more of the multi-services architecture. That's great. Let's look at the other changing factor, evolution of AI. Now, AI has been successful and much talked about since the mid and early 2000s, right? And it's been very, very successful in domains like image, in domains like speech, and now of the last 1 or 2 years, it's crossed a lot of hurdles in getting fully operational text models out there. And there's thanks to all the companies in the world who's doing great work on text. At the same time, for enterprise AI means that we need to be able to move into narrow applications like image recognition or handwriting recognition into more broader AI use cases. And this is especially true if we think that AI is going to be infused in part of each and every business process, right? So it's very important to understand that for AI to be infused in each and every business process, you have to move from narrow to broad AI. And this transition from narrow use cases to broader use cases that apply to healthcare, that apply to finance, that apply to retail and supply chain, it's important that certain dimensions are focused on. And yes, the research community is looking at the problems like learning from less data, because in a lot of those enterprise use cases, which is in contrast to consumer use cases of recognizing maybe images or recognizing sentiments in a sentence, a lot of this data is going to have to learn from unsupervised labels. Right? So learning from less data, learning without labels, these are fundamental breakthroughs that broad AI needs to bring in. The second thing I already talked about, it has to be part of each and every business process. It is no longer a neat data science experiment for building a nice recognition model or a nice prediction model on the side. It needs to be integrated as part of the business process, which means it needs to talk, it needs to get data from all your legacy systems, it needs to write to your legacy systems, it needs to continually learn from how humans interact with their legacy systems. So that's what AI for business processes really entails. If we have to infuse AI in domains like finance, healthcare, trust is key. Today, we work in hand in hand with experts in that domain so that we can make sure the AI has the same level of trust, robustness, as well as explainability as humans do. But this is a discipline that needs a lot of discussion, a lot of coming together of the who's who in the businesses to make sure that the AI we deploy is trusted. And trust is a complex phenomena. It has many, many dimensions. And I'll just leave it at that without the AI being trusted, without we being able to really understand the lineage of the predictions and the models, how they're evolving, what is their stability, AI will not be adopted, right? And then the last thing is AI for AI. Before AI gets ready, there's 80% of the work in actually getting the ladder ready, which means understanding what data we have in the enterprises and how to use the data. And all of that task and continually improve the data processing pipeline, continually monitor the AI lifecycle. We need to understand and employ AI for the purposes of AI. So AI for AI is another thing that we need to get very good at. So these are the 4 dimensions that will actually help us move from narrow use cases to more broader use cases, enabling us to be disruptive and pervasive. And then, of course, from this roadmap of narrower to broader AI, beyond that is really more general type of AI, which is revolutionary, where it can actually represent more of the human cognitive thinking and behavior. And it's still a few years away, I would say, right? So the evolution of AI, we can see from going from narrow to broad and along these dimensions. So again, to recap, we said hybrid cloud, AI, each have their axis of transformation that's going on. And one way to think of it is the cloud helps you build the strength and the muscle in your enterprise or your organization to be disruptive. And then AI helps you to be disruptive and pervasive in whatever is the domain of expertise that you want to major on, right? So the two go together. However, there is a closer linkage between the two, and it is indeed true as we talk about AI for business processes and AI for AI, that the AI itself can help our clients make this transformation as they move to the cloud. And this is the topic of my talk today as to how do I use AI techniques itself, not just to be built on top of the strength and muscles of the cloud, but actually use the AI to strengthen and develop the cloud technologies. So I'm going to touch upon 2 or 3 use cases where I will show how AI can be used in the domain of information technology. Now, of course, all of this is in the context and transformation to cloud. And just to contextualize it, imagine there is a customer who has a state of applications which are performing some well understood tasks managed by some experts of good expertise. And we are getting them through the journey of how to move that estate of applications and their business processes into the cloud, right? That's the problem statement. The problem statement really goes through 4 phases, which is the first one is the advice phase, where you look at the client's set of applications and decide what's the right technology or what's the right move for the client, depending on what are the business needs. And there's really no one size fits all, and hence advice is a complex space. It requires deep human expertise, but this human expertise can be aided by tools. And there is one tool that we'll talk about today, which is AI for Application Modernization, which can help clients understand and take advice on how do they, or which part of their application estate do they focus on for modernization first, right? Now, once you move through the advice phase, you get into move, which is really about how do I start making the transformations for the estate that I identified. And there are some decisions on rehosting, platforming, and refactoring that we need to take there. And then again, we will talk about another example there, how AI can help decisions in this move phase easier. And then there are also, many examples of how we can bring AI for building your applications correct and right, so that they can actually exploit the cloud computing native behavior. And then finally, how do you use AI to manage applications? For example, once you've actually moved and rebuilt certain parts of your application, how do you make sure that the application is always up and to the delight of the customers, right? So today we'll talk about some of these examples, but I wanted to lay out this umbrella picture so that you know that AI can actually play a key decision-making role in advise, in move, in build, and manage. And no discussion on AI is really complete without talking about data sources. And I want to bring to light that traditionally, as we move from our AI use cases through the narrow into the broader AI, we focused on mostly three types of data sources: speech, image, and text. Right? And we've been hugely successful. Like I was saying, the text success is more recent with the launch of the BERT and the transformer-like models with GPT-3, and that's all great news. But IT and cloud and the business of technology brings some new data sources. And these data sources need new scientists and researchers thinking about what are the equivalent BERT models for this data source. And this is where I will spend some time talking about a new discipline, which is AI for code, and it's hugely exciting. And it's brought to bear because we're trying to apply AI in this field of cloud transformation and IT transformation. All right, so this is a little bit of animation to tell you that where are the important decisions as I modernize to the cloud, all right? So let's say I have a custom application, which is my traditional applications shown in the green boxes, and I really want to move them into either a virtual machine or a SaaS or a container platform based on Red Hat OpenShift. Right, so let's say this is my current state, this is my target or to-be state. Now the applications don't exist in silos, right? They usually have some runtimes, and most real applications don't exist in silos. They have some runtimes, they have data that they access, they read from, they write to, they have middleware that support these applications, and then there are shared services. So obviously, which means that all of these boxes need to be modernized and need to be moved to the right target. So the problem, the problem statement here is that there are physical servers, storage, network topology, the complexity of all of that. On top of that, there could be virtualization layer or not. And then there are your middleware services, data services, shared services. That entire box needs to be modernized. So what's the decision-making process? In order to move it on the right, there are a couple of things that we need to do. One is we need to first understand, and this is, I think, step 0 of application modernization, is discovery of what the application topology is, which components talk to which pieces. Access and understanding of the code and its scalability, and access and understanding of the performance of the application, which typically we've actually used the term benchmarking of workloads, right? But now we need to bring this together of configuration discovery, technologies like CMDB to understand what is the topology of the application. What is the bring together my development system to understand where is the code distributed, how is it written, and then bring together performance metrics, which is really operational, to get an understanding of what the application is today. Because remember, as part of modernization, some things that are non-negotiable is really that the application logic, the application performance has to be improved and at least as is, right? So here, so given that set of constraints, you really see what are the intelligent decisions that you have to make. A, what are the feasible target architectures? Given that I know how the application is connected, this is how the workload behaves, this is how the code is written, can I really move the entire thing into 100% container architecture? The answer could be no. But it could be a mixed answer. It could be that, yes, you need to keep these components on virtual machines, whereas these run on containers. a decision making, right? A knob for us to put in intelligence and AI. The second set of decision, and you see the column, is really target engineering. How do I know now what I need to get from an application A to work just like before on the target environment. But can I actually optimize that application A to get better than what I was getting before, right? Which this includes, AI assisted decomposing. So imagine a whole monolithic app that now needs to be broken up into components that interact with each other. So AI assisted application decomposition is one such area. The other is that now they are going to run on this Modernize platform. Can I do more resource sharing? Imagine a set of database transactions being run by a big data application like image rendering, right? Can I optimize the resource so that all my database transactions that were taking a long time can be localized and can be much faster, whereas I batch those up and then transfer the results out in the cloud. And similarly, if that's indeed my middleware refactoring, where I move to a cloud-based database management system, can I even do the refactoring of the data services, right? So there's a whole set of decisions in target engineering. And then finally, there's another set of intelligence and some kind of automation that we could do in helping us get the deploy and the build faster on the new targets, right? So how do I translate my deployment artifacts? How do I make provisioning a single touch, single button? And yes, there's the role of AI in this as well, right? So modernize to cloud, step 0 is discovering the topology, benchmarking the performance, and understanding the code. And from there, you can span out into decisions of what targeted architecture should I adopt? How should I engineer now that I have understood what is the feasible set of architecture, and how do I do the translation faster? Right, so another look at what intelligent systems and AI-assisted systems could do in the advise, move, build, and manage phases. So advise, like I said, it's application discovery. Really understanding as an application runs, it leaves nuggets and breadcrumbs of information in either its testing logs, in its metrics, in the API calls that it makes out to another service. And of course, there is a lot of information in its code as well as in its runtime logs, right? So connecting these dots on what's in the code, what do I see in the runtime logs, what do I see in the performance metrics of the application, actually is a hugely interesting topology discovery problem. And if today there are tools that do this in a very, very fragmented way, there's really no one tool that can take in a complex state of an application map with all the middleware dependencies, with all the platform dependencies, and be able to give you a topology that's fairly, 80 to 90% correct. The other thing to keep in mind is that most of these tools that do these in bits and pieces depend on structured information, which is really tabular information that can be pulled from a CMDB or any other relational database. But there's a lot of intelligence that lies in the unstructured sources. For example, the logs that an application spits out, the test results that an application developer gets, maybe some incidents or big failures that happen with the application and the chat conversations. All of that is great information. Given the leaps and bounds we've made in AI and in text processing and understanding documents, we think this is a great green field to to actually apply AI to discover the application topology. The second one, which is more about application decomposition, is more about refactoring and goes into the engineering side. I now know where my application needs to be replatformed. I want to now look through the entire architecture of the application, understand the dependencies, understand the behavior, and then refactor it in a way so that I can actually get to the benefits of the cloud, but also reduce the manual effort by 5x. In terms of our benchmarking as step 0, if we found there are two very, very closely coupled components that have very, very different resource requirements, as a decision principle, it is best to decouple them so that when they can sit in the cloud, they can individually take advantage of auto scaling. Right, so AI-assisted application decomposition looks at code, and we will look at AI for code as a fundamental discipline that will allow this set of problems, this class of problems to be solved. And the final class of problems is really how do I, like I was saying, how do I manage better? Because now I know the topology of the application, I know what I've built, I know the dependencies, and really I can do causal analytics and dependency behavior to really get to root cause of downtimes, right? So that's really the third class of problems. And the most important thing is all of these need AI. These need AI running on the traditional artifacts of structured data, unstructured data like text, and then they also need AI to learn a new discipline of how to run on code. I'll give you a little bit of a visual glimpse into what application refactoring could mean, right? So imagine you have actually been able to discover through various sources of your documentations, of your tickets, of your WAR files, you have been able to discover what the architecture of the current application is. We have a microservice recommendation tool that, I mean, imagine if you are an architect and if you have this tool that takes in all these artifacts, discovers the application, and then with a click of a button. So look at the visual on the right, look at the dots and look at the hazy boundaries. The hazy boundaries are the recommendation that comes out of the tool that says, hey, today, all these dots are in single piece of code and as a monolith. And yes, I could rehost and make your application, make this entire set of dots run on a virtual machine or on a container. That's possible by technology today. But if you split your application along the blue lines and along the green lines, you will get much more benefits from the cloud. So in this case, it seems like the flight booking and the billing service, right? So this is a sample airline app, the booking as well as the billing. So after you book, you actually go and bill. They were together. They were together in the same piece of code, but there is a recommendation assist that says, if you split your applications along these boundaries, then guess what? You are going to actually be much, much more productive on the cloud. How do we do that? So we do that, like I said, on documentation. So there's documentation on the flight booking service as well as the billing service and the whole application. You do performance benchmark on what are the data service calls, what are the time taken for each of these flight booking and billing service. You understand what are the different parameters at play. You look at static code and dependency graphs generated for the entire piece of code, and you do historical analysis of how these two branches were developed, right? So given all of that, you can actually recommend this partitioning. Imagine, so this is a great tool for an architect. If I am an IT architect, I would love to get my hands on some of these tools. Now let's go to a different persona, a developer. A developer who now is given this task of generating the blue line and the green line microservices. Again, there is enough data to tell you what today these benchmarks are. What does the blue service achieve when it's running on a bare metal set of platform? What are some of its data dependencies? What have been some of the historical outages? The same for the green service. The developer could also be well aided by a sample generated microservice code that says, this is the template of the blue service. This is the code that I'm going to suggest you take from your existing service. And these are the new pieces of glue code that you will write, because today, now, you will be talking to a billing service that is exposed by a REST API, or you will be talking to a data management service that sits on the cloud and no longer on-prem. So this is your core code. These are the glues that you have to write. And imagine the delight and the joy of the developer to get something such well organized, and so that the developer, she or he, could just focus on what is the task at hand. So these are some of the ways where we can bring in AI to understand the artifacts. And I keep talking about, what does AI have to understand? It has to understand structured data like metrics. It has to understand historical data like documentation and what happened in history, which is text. It has to understand data dependencies, but most importantly, it has to understand code. Another example, and again, and we could think of, in your context, we could think of several other examples. As you move applications to new platforms, or you refactor some of them, there are many software dependencies that each application has. And over time, some of these software dependencies become old. And as you go towards re-platforming and rehosting some of these applications, these dependencies need to be re-evaluated. Imagine if you have an assistant that tells you that if you want to move to from Apache Tomcat 6 to Apache Tomcat 7, these are the application binary, application dependencies that you need to also upgrade or move. And this is what it means as change in your code. For example, certain libraries might have been deprecated, being replaced by new libraries that take different parameters, but all of this out at you in a single screen pane of glass that says, okay, I accept this change, go ahead and move, create this transformation for me from 6 to 7, and so on, right? So migration, again, requires AI, requires understanding of change logs, which is really a text understanding problem, requires understanding of how do you ensure that the application behavior is unchanged? Because like I said, that was a constraint. We at least have to do as good, and the goal is to do better as we move to the cloud. All right, so enough on modernization. I want to touch base on two other things that we saw in this whole umbrella of advise, move, build, and manage. But this is the view. This is what I mean when we say, every business process is going to have to be infused by AI. And this is what every business process owner or stakeholder in a company cares about. For example, customer service. We all know that's the landing place of AI in many organizations, right? You have a problem, you have a set of people attending to those problems. As we see repetitive patterns, transfer them to conversational AI or a chatbot. And that's one of the hugely effective and successful areas of AI. However, there are other areas like risk and compliance, which is very manual, and we absolutely need to see how we can get in assisted toolings, just like we were doing for modernization, into there. And IT ops, right? So I'll talk about IT ops and take this example where our CIO, our respected, trusted CIO is the stakeholder, and how can we use AI to enable operations and management of the applications we have built with so much care. We've refactored, we've reorganized, we've re-architected, but now we need to manage them better. right? So let's see what that means. So what does a managing an application means? It means every time I need to access the application as a customer, I should be 100% successful. Well, that's a stretch goal. Never have any outages is really a vision to have. But even today, a lot of the major SLAs that cloud service providers have, they don't allow you outages for more than, let's say, a couple of minutes a year, right? Now, are we, with the current set of technology and tooling and all the expertise that we have, are we able to manage those SLAs? Unfortunately not. So see today what we have to do, as if we are a system admin, or as as the cloud system admins are more fondly called today, we are site reliability engineers. So today, when there is an outage, you go through many different tools and there are different levels of fragmentation. Today, in terms of management, there can be anywhere between 40 to 60 tools. But imagine there is a PagerDuty alert that comes to your system that says what's wrong. The sysadmin or the SRE goes to PagerDuty alert. Then there's a log aggregation tool which you consult. Then there is an APM tool that tells you if your metrics are healthy or not. And finally, there is a ticketing tool or log management tool that you have to really look at what does similar tickets say, and what do the application or the system logs say, right? So today it's no surprise that it takes multiple hours, and our analysis has shows that it can take anywhere between 4 to 10 hours, 18 handovers between expertise and people, because like I said, if you remember that box I showed you, applications are complex. They're not standalone piece of code. They have runtimes, they have database dependencies, they have storage dependencies, they have networking. So the teams who are going to manage an application, it can be anywhere between 4 to 5, right? With the storage team bringing in their expertise, networking, and so on. And it's not possible to have a person or a set of team who understands the entire breadth. But what is possible is easier collaboration, easier exchange of artifacts, AI being able to connect the dots across the storage, the networking, the compute, and the application middleware layer to really say, here is where I see the problem is, right? So about 17 number of steps, which is really a large number of steps. 10 people involved in any critical outage, and then the cost of each of those can actually be about more than 100K. So it's definitely a situation that needs transformation. It's one of those areas where there's loads and loads of data, and we have to learn from unsupervised labels, because it's impossible to expect that you are going to get a whole lot of labels in this IT data. But data is not a problem. Data is in all forms and shapes. It's in structured data with APM metrics. It's in semi-structured with log data. It's unstructured with ticket data and conversations in chat rooms and emails. And you have the whole gamut and the whole breadth of complexity there. So what's the tomorrow? Just like we saw in modernization, what are the axes that AI can help? So first of all, there is a lot of value in being able to detect an alert with AI, right? Because sometimes when people write rules with these systems, you can for one issue that spans across multiple systems, because they have multiple dependencies, you can generate hundreds and thousands of alerts. So you need AI to be able to filter, prioritize, group, and actually bundle them together and say, oh, okay, I think all of these are dependent because I know the application topology. I've discovered it, remember, using my step 0. And then I prioritize this single alert that you should focus on. So that's an issue detection problem. The second is artifacts gathering, right? Let's say you've decided, okay, from those thousands of alerts, these are the 3 I should look at. Let's start looking at what other artifacts I can gather. Let me pull out logs from all the affected systems. Let me look at past incidents. Let me look at the APM metrics. And let me look at all of them and see if I can use my highly evolved causality techniques to say, where does the issue lie, right? Now, once I know I have ballparked or I have a sense of where the issue lies, then I could start doing diagnostics. And diagnostics could be collecting more data, doing more tests, or could be landing on a localization reason that seems the most credible. But having said that, I think diagnosis and resolution are also two stages where the trust and the explainability becomes very, very important. I'm telling you the problem is with this database management system, not because, and you should trust me, not because I'm AI enabled, but because I have these supporting artifacts, right? So that becomes very important. The final resolution, of course, is where it can be human assisted to say that these are my diagnosis, these are the steps that I could recommend, and maybe there's a human, maybe there's enough repetitive behavior to actually go and resolve the issue. So this is how we see AI transforming, creating the tomorrow that I talked about in my last slide, and reducing the time from couple of hours to couple of minutes, a couple of steps of detecting, analyzing, collecting, diagnosing, and then reducing the overall cost of an incident. And this is real, right? So the reason we have Slack there, and it could be any collaboration channel, the new way of bringing together all these different experts of people to collaborate and talk about how they diagnose an issue is invaluable because it creates labeled data while people are at work, right? So you bring insights into their realm of work. They look at these insights, they give you feedback, they either accept the recommendation or they don't. Either way, the AI learns, right? Which is why the collaboration channel, something like Slack, could be Microsoft Teams, really acts as your platform for both infusing the AI, where you land the recommendation, but also gather information about it. So I think I'm at the end of my time, and I will wrap up. The last thought that I wanted to land with is that all of these needs a new domain, and we can completely see, in addition to speech, text, and vision, code evolving as a fundamental unit where AI needs to be applied. And yes, it is definitely the need for the cloud transformation journey, but I'm sure it's going to be the need for, as we do many of these platform infusing with AI. Code is the language of machines, and code is everywhere. And we all know the story of Uber, of Airbnb, of Netflix, who did not start out as software companies, had a business case, but reuse architectures, platforms to really disrupt the market. And that's where Mark Anderson had predicted. This was, of course, pre-Uber. We're still not done. We still predict that over 10 years, software-powered insurgents will be epic. And because of this, we need to evolve the AI. Just like we evolved AI to learn on language, we need to evolve AI to learn on code. And with that, I think I'm going to pause there with this final slide that we need language processing, we need processing techniques and machine learning that understands code or software artifacts. We need decision making and reasoning, just like we had QA systems. We need systems that are able to understand and make decisions for systems of code, and we need explainability as we process code. So my final slide, I'm Gargi, I'm part of IBM Research. We do a lot of cool work, majoring in hybrid cloud and AI, and these are the footprint of our labs spread across 12 centers, each having a center of expertise. So thank you, and I am going to stop sharing and be ready to take questions. Vajanti, I think we cannot hear you.
Gone on mute. I'm so sorry. So I was just thanking you for an excellent session, Gargi. And in fact, I have a few questions lined up for you. And the first question is, what type of background and coursework would you recommend for someone who wants to get started in AI or someone making a career change?
Yeah, so that's a good question. I get that quite often. So I have a very prescriptive approach, either whether you're doing a career change or when you get started. There's tons and tons of resources out there on the web. The first set is actually free, right? So, and those include all data science resources, understanding how the discipline of statistical machine learning, right, has now evolved into this new era of deep learning. So I would suggest start with a lot of reading on statistics, right? Get maybe some courses on Coursera, and some of them are free, some of them are paid. Stanford and Harvard have excellent courses, but get started with courses on statistics and mathematics, understand what machine learning statistically used to be, and then understand, how some of the new age techniques of deep learning and reinforcement learning are changing the game, right? So that's my recommendation. So start with some reading, take some courses, and thankfully there's plenty of material.
Thank you, Gargi. And I have another question, a quick one. Where do you see AI making the earliest and largest impact? And how long do you think it will take for AI to mainstream and broad?
Largest impact, where has AI already made largest impact? Obviously in the life of consumer, in life of us, right? How many of us get up talking to our Alexa or using our Google Home today? Every day, right? And maybe about 80 to 90% of us. So largest impact has been in consumer space. On the enterprise side, right, and which is where we really need to make the transformation, the largest adoption has been on customer care. Chatbots, conversational AI, they are, every company, like I said, which has a very defined business needs, puts them out there. It helps clients. Is there a need for improvement? Absolutely. And that's what the AI scientists and researchers all around the world are working. Where do I see it becoming part of mainstream? I think it's already part of mainstream. It's getting there. Like I said, a lot of those examples that I showed you on refactoring and management, those are what we use today to talk to our clients. There has been infusion in supply chain and manufacturing. We just hope, to double and triple that in the next couple of years.
Thank you, Gargi. And I have a very nice question for you. I think, you quite often you come across this kind of question. So here, the viewer is thanking you for an excellent presentation that included a lot of practical stories to utilizing AI and then modernizing our system. The question is, from work-life balance perspective, how do you manage your life and work? Imagining, as a director, you must be super busy. If you could give us a good advice not to hesitate to be promoted, that would be fantastic.
Yeah, absolutely. So I think obviously we get this question quite a lot because as women, we tend to juggle with multiple responsibilities, and for some of these responsibilities, we are the key stakeholders. So work-life integration, at least this has been my personal story, has been more effective and important to me when my kids were small, right, and they actually needed me, I decided to take that time out for them, which means, be with them, prioritize when they are sick, where there are certain things to be done for them, work with them. But as they grew up, I think it was important for me to make them understand that how important the work and this field of technology. And I think also they understood their mother, they understood, what it brings to me. And so we integrated our lives, right? So it wasn't so much of a balance. There were still certain things that needed to be done in school. But when they were sick, they could take care a little bit of the by themselves. They would actually say, go. In fact, today, Vajanti knows, I am fighting a personal situation with COVID at home. But my kids said, go and do your speech because this is what you care about.
Yeah.
So integration and, helping them understand me, what is important to me, has been the key that has worked.
Super,
And I think one more question, Vajanti, I must admit, is that, don't try to do everything. I just said, okay, these were the top 2 priorities, and the rest of them get enough help.
Thank you, Gargi. That was a superb thing, actually, and so professional. And we heard what AI techniques can be used for these new data sources from Gargi. Very interesting talk, and we thank Gargi wholeheartedly once again for this fine opportunity and also responding to the questions raised. And with this, I would like to conclude the session. Thank you all for your active participation. Stay safe and stay healthy. And Ms. Cotter will chair the next session. Kindly wait. Thank you very much. Bye-bye.